Hi, I've missed a section in here, so I'm going to have to go back really quickly and give you this information. So this is section 2.3, part of section 2.3, which is kind of right after we talk about the structure of the atom. We know we have protons, neutrons, and electrons. And then right before we talk about the atomic weight, the average atomic weight there. So there is a way in which we can give you this information about how many protons, how many neutrons, how many electrons without having to say all those words out. So really quick recap, an isotope, iso means same and tope means place. So same place in the periodic table. Their isotopes are atoms of the same element but with different masses. We've talked about this a little bit before, or maybe you haven't gotten to it yet. This video here, I mentioned it there. This is where I should have introduced it, but with different masses. So what does that mean? We mean we have the same number of protons because that's our same atomic number. If they're the same element, they must have the same number of protons or the same atomic number, but then that means we have different masses. And if protons and neutrons make mass, then we must have different number of neutrons. And so our mass number is the number of protons plus the number of neutrons, because the only ones that we think about as having mass are protons and neutrons, right? Electrons do have mass, but that's so small in comparison to protons and neutrons that we don't really consider it. And then another thing we want to think about, and I wrote this before, is the charge. The charge is going to be the number of protons minus the number of electrons. Minus for electrons because electrons are negative. So it's easier just to subtract. Instead of adding the negative charge, it's easier, I think, in most people's heads just to subtract the number of the electrons. And we don't include neutrons here because neutrons don't have charge. We don't include electrons in mass number because we don't consider electrons to have a big enough mass to be counted. So how can we put all of this information kind of into one notation? So what we do is we put the chemical symbol, so X is going to stand for the chemical symbol or the element symbol. And I'll give you an example as we go. So for example, we'll do Cl. So that's the symbol for chlorine, Cl. On the top left, we're going to put the mass number. Again, that's going to be our number of protons plus neutrons. Let's just use, for example, let's say 37. Now, if you look on the periodic table for under chlorine, you'll find that chlorine is number 17. It has Cl and it'll say 35.45. Remember that this number, if you watch this video, is average atomic mass. And it's a weighted average. That's why it's a fraction. So average mass. So if I say, hey, the average height of everybody in our class is 5'7" or something, right? Or 5'6" or I don't know, average height. That does not mean every single person is that height. No. So if average for chlorine is 35.45 or around 35, this one that I'm particularly talking about is an isotope of chlorine, and it has a mass of 37. So it's a little bit of a heavier chlorine, but it's still chlorine. Put our atomic number on the bottom left. Sometimes you'll see chemists put this, and sometimes we'll leave it blank, because to know it's chlorine is to know its atomic number is 17, because they are the same thing. So if it is chlorine, it's got 17. If it's 17, it's chlorine. So sometimes you'll see us not put anything on the lower left corner, and that's just because it's a little bit redundant, but you'll see it in homework and that kind of stuff, as I usually try to put it there. And then if we do have a charge, we'll put a charge on the top right, if any. If you don't see any number there, you know the charge is 0 and your protons and electrons are the same. However, if I did have an example of like a charge of chlorine usually has a -1, I might put a little negative there, and that's going to indicate a charge of -1. which means we're going to have one more electron than proton. I cannot change the protons to change the charge, because if I change the protons, I'm changing everything. I'm not chlorine anymore, but I can change the electrons. And so let's break this one down. So if I have 37, 17, Cl negative, how many protons do I have? Protons go with the atomic number. I'll put this up here as well. Atomic number equals number of protons. And I didn't use equal signs here. I used colon. Okay. So protons will be 17. The number of neutrons comes from the mass number. So if mass number is number of protons plus neutrons, let's take out all the numbers, protons plus neutrons. If my mass number is 37, my protons are 17, I can figure out what my neutrons are, right? So my neutrons will be whatever 37, so neutrons would be 37 minus 17, which would give me 20. So my number of neutrons here would be 20. If I don't give you information about specific mass, I don't say chlorine 37, I just say chlorine, you can assume average and just say 35. And then for electrons, we would need to look at the charge. So the charge is equal to protons minus electrons. So the charge is -1. The protons are 17. And I don't really like to do algebra for this one. I just think about like 17 minus what is -1? Or, if you need to be you need to be one more negative than 17. So how many electrons do you need? 18. So 17 minus what will give you -1? So my electrons are going to be 18. However you want to think about that, if you want to do it algebraically, I think it's probably more steps to solve for something with a negative sign, and just thinking about it rationally may be quicker. It's up to you. We have one more electron than proton. So this is not neutral. We call this an ion. Ion if not neutral. You will always assume neutral unless told otherwise, but if I do give you a charge, then you're technically an ion. And then another way we can write, we could say chlorine, if we want to name it, we could say chlorine 37. And this is going to give me the mass number. So another way we can kind of talk about the different isotopes would be the name of the element. And then we write a dash, and then we put the mass number. And that's kind of a way that we can quickly just tell you what the different isotope is. And we'll talk about how we name ions a little bit later, but those are just some ways in which you can take all the information about number of protons, neutrons, and electrons, and then have it kind of in a quick, easy to reach kind of way. That's it. So if you have any other questions, let me know.